Welcome to Building Command Line Tools with Tooling API. I'm Jeff Douglas. I'm really excited about this session because two things. I love the Tooling API and I hate making UIs, so I love the Tooling API. I don't have to worry about any design stuff. So it's going to be a fun session. You can follow me at Jeff D in the mic. You can tweet me. I'll try to tweet back to you. But I didn't want to really just do a bunch of slides today. I want to do some slides and go into a bunch of demos. So there's going to be a lot of code. It's going to be all JavaScript, so we're going to write JavaScript in Node using Enforce. Doesn't mean you have to use JavaScript when you're doing the Tooling API. You can use anything that supports SOAP or REST, so your mileage may vary on what you do here. So, all right, so, off to a rocky start. Okay, Safe Harbor. I know you all seen that. You all love it as much as I do. You probably read it as many times as I do, but basically don't make any forward buying decisions based on what I'm going to say here today, all that good stuff. So. Again, that's me. I'm a developer, evangelist, architect at Aperio. I work on the Topcoder platform. I've been a long-time Force.com developer. They told me to give my street creds out here. So I'm a certified administrator, developer, Sales Cloud, and I was one of the first Force.com MVPs back in I think 09 or 010, something like that. So I've been doing a lot of work on the Force.com platform. I do work on Topcode every day. I do JavaScript and Apex and Objective-C and all kinds of things, whatever comes down the community. We do all kinds of work. All right, so here, let's get started. So enough silliness about me. So the Tooling API. What is the Tooling API? It's an API to build tools on the Force.com platform. It's a little different than most of their other APIs. It doesn't interact with records like accounts and contacts. It actually works on the underlying Apex and code and the metadata that you have in your org. Similar functionality to the Metadata API, if you guys have used that, that's all SOAP-based. This can be SOAP or REST, so it's a little bit easier to work on web applications if you want to use the API. I use the REST-based one. It seems to be much easier. Slightly different workflow than most APIs, and I'll get into that later, but it's kind of hard to grok. It's not like you see with regular APIs. There's a lot of things going on in the covers that you've got to work with. So I've made it a little simpler, and I'll show you how we do that. And you've probably already seen it if you didn't know it. At the bottom of the developer console, there's a tab that says progress, and if you do stuff, you can see it spinning through there with all the records with the what's actually happened under the covers with the Tooling API. All right, so to use the Tooling API, a lot of different ways. I mean, of course, I said you can build tools, but what does it actually do? What kind of tools can you build with it? So we've done a lot of stuff at Aperio building tools with Metadata API. So you can use it to automatically deploy your code in metadata. So if you guys used Maven's Mate at all here, so Maven's Mate uses the Tooling API under the cover. So when you enter your code in Maven's Mate, you hit save. It's actually using the API to deploy that to Salesforce for your org. We use a lot for big projects. So if you have a project with a large number of developers, large number of developer orgs, you can use this to keep these two orgs in sync, or these multiple. You could still use Git. You could pull every day from the master repo or the master branch in the repo to keep everybody up to date. But this is kind of cool. We'll go through a use case and how we can keep multiple orgs up to date by using the Tooling API. Code analytics. You can get all kinds of cool analytics out of the Tooling API. My buddy Andrew Fawcett's got a great blog on how he did spring cleaning on his org. He ran the Tooling API against all of his org, and he found out which methods, which classes were not being used as Apex code, and he was able to delete that code out of his org and kind of cleaning that up. We like to do it all for reporting on your environment. So we have a couple orgs that we actually run this against, and it generates reports for us. So it'll spit out the reports to a text file, and we can then run diffs on these different orgs to see, if this org's missing a field, this one's missing an object, where the deltas are between those orgs. So that's a really nice thing. We do that on a time basis. We have a cron job that runs every day and does all this reporting for us. And then you can also use it for daily smoke tests of your org. So let's say you've got an org that's in rapid development or migration, and you want to make sure nothing's broken during that process. You can set up a task that runs every day that runs all your Apex classes, or just a few Apex classes, runs a test, maybe alerts the developers that they're failing, or maybe even email them if the code coverage drops below 75%. So there's a ton of things you can do with the API. It's getting better all the time. Each release, they've added new things. Like this release, they just added we can run all tests. But I think it's eventually going to take place of the Metadata API. That'll probably go away in a couple years, and this will replace it. This is the new thing that they're working on right now. It's pretty slick. So what does it actually do? So like I said, most APIs work with records. This one works with metadata, and you can do all kinds of CRUD operations with it, metadata or the tooling API. So you can delete, you can CRUD basically. So create, update, and delete Apex triggers, Visualforce pages, validation rules, static resources, workflows. You can manage custom fields on custom objects. So you could say, I want to create a field in this custom object. I want to change the label. I want to increase the field size, and then I may want to delete it. You can do all that with the Metadata API. Execute tests synchronously or asynchronously. I'll show you that in a second here, but you can run all your tests on a single object or on your entire org, and it'll give you code coverage back. What's your entire org-wide code coverage, specific class, and what's their code coverage, and I'll show you that in a demo also. I really want to do demos, so I'm trying to get through the slides. And then execute anonymous Apex. So I can send a chunk of code into the API, and it'll run it against the org and bring you back any results. And then we can also do set heap dump markers. This is pretty advanced. We're not going to cover this, but you can actually inject Apex or SQL statements into your code at certain points, and that'll generate a heap dump for you, and you can go ahead and analyze that and see what's going on underneath the marker. So if someone says, hey, I'm having problems here, it's not working right, you can set some heap dump markers for it, and you can look at actually what's going on during runtime. And then we also you can access the debug logs, and the symbols are actually pretty cool, really advanced. I mentioned that's where Andy Fawcett was picking apart his org for spring cleaning. But it's cool because you can actually run it against your class, and they'll tell you, what the inputs look like. So here's the actual method names, and here's the inputs, parameters, outputs, what it returns, all kinds of cool stuff like that. And you get that back as like an arrays that you can access programmatically. So if you like strongly typed language like Java and .NET, which I've done both for quite a long time, you may want to choose the SOAP service. If you like the dynamic, scripty feeling of JavaScript or Ruby or Python or anything else that supports REST, pick that. There's a little bit less functionality in the REST version. You don't really notice it that much, but some things just aren't available in that. I have the feeling they start out with the SOAP version first and then kind of roll back that functionality into the REST version. But it operates almost basically all the same, so that way you can use any language you want or any type of bindings you want for your services. So I talked about the whole thing. I said it's a little bit harder to grok the process of actually using the tooling API. It's not like you just submit your code and it's gone. So what actually happens is when you have, this is an example of updating Apex code. So the class already exists in Salesforce. I'm adding my new code and I want to deploy it to the server. So the first thing you do is in the middle, you're going to create a metadata container. And you're going to take your new code and you're going to add to that container. And then that's called the Apex class member. Then you take the existing Apex class and you add that to the meta container, and that's got a reference to your actual class in Salesforce. And then you deploy that. And that's going to spit back a container async request ID. And that's the ID you use, and you keep submitting that to Salesforce and check it and check it and check it and check it until all the tests come back either passed or failed. So as you check, it'll be queued, and I'll show you that in a second here. It'll be queued, and then all of a sudden you'll see some go from queued to passed, and then queued to failed. At one point in time, they'll all finish up, and you'll be doing your deployment. It's kind of hard to grok, but I actually wrote some software that I'll show you right now that actually makes it a lot easier to deal with in that pattern. Which actually is a great segue, by the way. So if you guys have done have you ever done any Node development here with Salesforce? Okay, so you probably ran an Enforce, right? So Enforce is my buddy Kevin wrote this. It's a wrapper around the REST API for Salesforce. It makes dealing with Salesforce REST objects with Node extremely simple. He's had it out for about 2 or 3 years now, documented very well, tested very well, and everybody used it for a long time. We've got a ton of code that shows how to use that. So I got with him about, 6 months ago, and we wanted to do a plugin for that. So I said, I want to do the tooling API, and I wanted a plugin. So we developed the architecture to do a plugin. So I wrote a tooling API for the plugin. It makes it much easier to do all the tools, all the functions I just spoke about. Like we just deployed some code. It makes it much easier to deploy that code, and I'll show you how it makes your life so much easier. So it supports most of the tooling functionality API, so when a new function comes out, when release, I'll try to go back and update it. But if you have pull requests, you want to help contribute to it, be glad to take pull requests for functionalities. There's no bugs, I swear, but I do get bug reports once in a while, but I love having people use it. I think it's a super API, and you can't beat Enforce for writing web apps. All right, so we're done with the slides, and we're going to hop into the demos here. So anybody got any questions first while I'm doing that? Everybody's good? Okay. All right, so the first one we do is we have the session where we talk about we're going to build command line interfaces with Node. So there's actually a tool called Commander, and it makes building command line apps with Node extremely simple. So let me make this a little bigger. You guys can see this. All right, there you go. So it's very simple. You can see all we do is import commander. Here's our configuration. And this is the library that contains all of our integration with Salesforce. And then these are your actual runs, your actual commands you have through here. So we have one that gets all the objects, we have one that gets a certain object, one that describes the object, and queries for objects. And so it's pretty straightforward. I'll give you an idea of what the actual CLI looks like. Let me get this down here. So here's the CLI right here. Okay, so you can do things like help. Oh, let me try it again. And it gives you all the uses that you have for that CLI. So you can do things like, so we want to do, let's do objects and see what we have in this org. So that brings back a list of all the items that we have in this org. You might want to use that if you want to program out to figure out what you have in this org at runtime. So that's pretty cool. And the code for that is pretty straightforward. So we can look at here. Where'd my code go? And the code's pretty straightforward. So it's in our package here. And all we're doing is we're doing the standard boilerplate stuff. So this is, it pulls in your Enforce. This pulls in Enforce tooling. Here's our configuration. We use Q. Everybody familiar with promises? So promises help you write Node easier because Node is asynchronous, so you could fire off a function and it may not return for a while, and you never know where it returns. And it's hard to orchestrate different calls in a row. So you kind of use promises, there's a library called Q, to actually synchronize asynchronous programming. So it makes it much easier. So if you've used Enforce, you'll notice this is the boilerplate, create a connection to Salesforce. You have to pass in your client ID and your client secret and stuff like that. And here's we added the tooling plugin. And then you go ahead and you actually log in. So you log in, you pass your credentials over, and it logs you in. So after that point, you can start running commands. So the command that we just saw to create a list of objects are really simple. You log in, and then after that finishes, you call the tooling API and say get objects. Then when that finishes, you just display the results of that call to the screen. Pretty simple. Another one we have is, let's see what's the next one. Another one we have is when you get a certain object. So we'll do object A. We'll go get an Apex class. You guys see that okay? Make it a little bigger. There you go, Apex class. Then we'll get some basic information about an Apex class. The Wi-Fi seems to be pretty slow here. There we go. So there's the Apex class. You can see it's describable, the creatable functions, custom settings, the URLs down here. So that's pretty standard. It looks like this. So it's just basically, again, log in. After you log in, you're going to go ahead and call the tooling API and get the object, and you just pass over which S object to get. Pretty straightforward. And we'll just run through one more. And then you want to do something like, let's say, get, let's go ahead and describe. And this brings back a ton of stuff. It's almost too much to show, but it just scrolls off the screen. So that's if you really want to know everything about this object, this Apex class object, because everything in the tooling API is an object, you can go ahead and filter through that and find the parts that you're looking. Then the last one we're going to do is I want to query. So I want to see what type of objects I have in there. So I may want to see what are my Apex classes. So I'll do and I had this set up where it just basically brings the ID and name field back from all the Apex classes. So I have just these 6 or 8 Apex classes that I have currently in my org. So I can do that. So, and again, the code's pretty straightforward. We use the tooling API, using the tooling plugin for Enforce. It's pretty simple. I just pass over, once I log in again, I just pass over the query I want to run, to send that to the tooling API. It runs that query and brings back the results. Pretty simple to build a command line tool that you can either integrate with your existing workflow. You can script that if you want to. That's all part of what you get with the great things of Node and having actually a file that runs as a plugin or as a CLI. So that's just some basic things with Enforce and the tooling API. What I was going to show now is more or less some of the things we talked about before. Like we have different things to do with, we said, what if you want to keep multiple orgs in sync? So you may have a process where you want to, every time you have a developer who works on a project and he saves his code, maybe deploy it to 6 orgs or whatever, something to that effect. So you can set up where you can have Node watch a directory. So it may watch your force.com directory, or it may watch your Maven's Mate directory, and every time code is dropped into that or saved to that directory, it's going to go ahead and actually deploy that to the server. So I'll show you that real quick. That's pretty slick. So I have a little library in there, and all it's really doing is just watching the directory. That's all it really does. So I'll go over it real quick, and then we'll see. Actually, I'm going to run it first. No, we'll run it first. So what it do is you can actually run this in the background. So if you want to run this as a background process, it's just going to sit there and just look and watch for this directory for files to be dropped in there. I'm going to run it from just the command line now, but you can use a package called npm forever, and that's where you can start a process of background and log out events to a log file and look at them that way. So let's see. So I'm going to start this up. So we're going to do node watch. All right, so it's connected to Salesforce, and now it's watching for files. And what the code says is, it's pretty cool actually. It actually says, same thing again, we got all the information up here, required enforce, the tooling API, queue, and then we have this is actually the package that watches the directory. So there's our boilerplate again for creating the connection to Salesforce. And here's the authenticate again. And once it authenticates, it's going to go ahead and just start watching this directory, a certain directory right here. And it's going to watch whenever a new file is placed in there. So let me go grab this real quick. I should have had this open. So what I'm going to do is I'm going to grab this code right here, and I'm going to drop it in. I'm going to drop it in this directory right here, because it's watching this folder right here. And as I do this, watch the screen right here at the bottom. You can see that it'll actually deploy this code to Salesforce. So there's that right there. It found that code, deployed, and then deployed to Salesforce. You can see it says, OK, I found a piece of code in this directory, and I deployed the code to Salesforce. So now if I log into Salesforce, I'll see this here. Sorry, the Wi-Fi seems slow here. There's that class here. So let me delete that again real quick. And you can do that with multiple. So if you have multiple files that go up there, you can do the same thing. So let me. So we'll watch this again over here. We'll drop that in there. And it's pretty fast. So there it goes, deployed the two-class Apex. So you can see how you could drop or save files, and it would deploy to multiple orgs at the same time to keep these files in sync. And it'll throw back any errors that you might have. And again, it's a nice thing to have. We just have it sitting on a server, and it just keeps watching for files all the time. And the way that happens is, it actually finds that code. It says, when it finds some code, it actually runs this deploy function, and it passes over the name of the file that it found in the directory. And it takes this file right here. It figures out that it's going to have a class name because it's going to be something.cls, so it chops that CLS off there. It finds the name. Then it says, OK, go get the code. So it grabs the code from that directory. It just reads the file in, nothing too exciting. And then it creates the Apex class in Salesforce, passes over that name and the body of the class. So that's all the code I have in there. And then it goes ahead and deploys that. So the create Apex class is really simple. It just says, use the tooling API for Node. Going to create a new Apex class type, and it sent me the object in. And the object was the name field and the code that it's going to use for that class. And just deploys it up to Salesforce. And it just checks when that's deployed. Very simple. Much easier to use this than REST API. This is a nice wrapper around the tooling API. So that's an easy way to keep things in sync. So one thing we want to do also is, we mentioned, was the harder thing is running tests, because it's all asynchronous, and you never know when it's going to finish like that. So I have this little script here that we can use to do a demo on how you actually run tests in here. We can look at this code real quick here. Let me make sure this was deleted, because we're going to need that. So what this code does, it actually is going to, I have actually 4 pieces of code in here. So I have in here, I have the tooling API, the tooling test, and then a test class for each one of those. So what I'm going to do is it's going to actually grab the 2 Apex classes and the 2 associated test classes. It's going to deploy them both to Salesforce. Now, it's got to do them asynchronously because it has to, you can't deploy the test class before the actual class is there. So it's going to deploy both the classes first. Then when that's finished, it's going to deploy both the Apex test classes, and then it's going to start running tests. So when it runs, kicks up the test out, it's going to bring back an ID, and then we're just going to keep checking and checking and checking for the results of that test. And it's the same test as you would run in Salesforce. We can go in here and see that these classes are actually running, and you can look at the developer console and see that it actually ran those tests. So let's go ahead and run this real quick. So we'll do. This actually works pretty fast, so keep an eye on the bottom of that there. So it's going to, again, I'm in the wrong pipeline. So I was in the wrong directory. Okay. Okay, let's run some more time. Okay, should run pretty fast. Okay, so they're running tests asynchronously. Inserts the two classes, inserts two test classes, gets the job back. You see the async run ID, job 707, whatever, checking the status of all the jobs repeatedly, but it comes back really fast. So we get the test results. So the first test failed because I write a lot of tests that fail. I'm really good at that. And so you actually get the assertion that failed and the name of the class and the line number and column number in there. So you can see everything that's going on. And then the next class, tooling test 1, that one passed, and you get the code coverage for just that test. You get 33%. You get the lines covered and uncovered, and actually which are the uncovered lines. And then as everything's complete, it resets the environment. It deletes all the classes out of Salesforce. That's much easier than doing it just pure with a REST API. This takes away a lot of that stuff for you. So let's run it one more time and see, because it's pretty fast. So that's it, to do all those functions. So it's a lightning fast API to do all that. You'll see it once in a while if they're deploying a lot of code or something like that. You can see it sometimes test classes take longer, but typically it's really fast. So let's walk through this real quick. I'll kind of show you how much easier this is than just using the REST API straight away. So, okay, so again, we've got our enforce tooling, enforce, and we use also events. So in Node, you can listen for event emitters. I'm not sure if you're familiar with event emitters. It's kind of like with Lightning. You have events that you actually throw up in the air and different parts of your code listen for it and then act accordingly. So we can pass event emitters, and then we also use promises, which run asynchronously. What this does is actually it runs code, and then it just starts a mini event that says, hey, I'm running code, or hey, I'm compiling code, or hey, I'm checking for tests until they come back. So we'll go through this real quick and see. There's the connection for enforce to Salesforce. There's our connection. And then once it connects, it goes ahead and actually deploys the Apex classes. That's the first thing it does, is it deploys the Apex classes. Let me go down here and show that real quick. It deploys the Apex classes. Here we go. So it basically goes ahead and grabs all 4 files from the directory right here. You can see it reads all those four files. And it goes ahead and actually deploys those to Salesforce. It says, okay, for each one of these, go ahead and deploy it. And here's the class, and here's the code. And it inserts into Salesforce, and that's where you get this line right here. Inserted Apex classes, tooling test 1. It does that for all 4 classes. Then after we deploy that, you see it emits an event called start. So it broadcasts to everybody listening, hey, I've started doing tests. I've started doing something. So we have the event emitter listens for that, and this one actually says, okay, I'm going to catch this event start. And all this does is says, okay, I'm going to kick off the run tests, and I'm going to send the IDs. It's an array of IDs of all my test classes. Not the Apex class, but the Apex test classes. That confused me a little bit. So it says, run these tests. Here's my test classes. Once that comes back, it says, I've deployed those successfully. They're actually running. I've kicked off the job. And it says, okay, now I'm going to emit the event. Start checking for status. Let me go check and see if this thing finally finishes up, because it doesn't run at a certain amount of time. So we catch that in this function right here called status. And that's why you get the part where it says checking status repeatedly until this job completes. And it just keeps calling. It keeps calling this function repeatedly. So you see down here, it says, here's the job ID I'm working on. And it just keeps calling this function right here repeatedly until it gets the right response that it wants. So you'll see that it says, it checks, okay, it says, give me the status of this test. Here's the job ID. And it looks at, this is just a little package that says, give me all the IDs and the statuses for all these records. And it just checks to see if they're all complete, is what it's really doing here. And once they're all complete, if they're not complete, it says, okay, let's go ahead and run this job again and check for this job again. See if it's done yet. And then once they're all either a status of completed or failed, it's going to run this code here, which says, go ahead and emit the results event. So it emits the results event, this one catches it, and this basically just goes ahead and calls the tooling API again and gets the results and starts outputting your results. So it checks for each record that comes back because each test in your Apex class is going to have a different event because you can have one test fail and one test succeed in your Apex class. So it's going to loop through each one of those, and if it fails, it's going to tell you what the line number was that it failed on, what the exception was, and then if it succeeds, it's going to output things like, here's the test class, here's the lines that are covered, here's the uncovered, and the percentage. And then when we're done, we're going to go ahead and it actually throws a complete event, and the complete event just basically cleans everything up, deletes all the Apex classes out until it's done. So that's the portion demo. I did want to show you one more thing. So I showed you a bunch of tools you can do with the tooling API, but you can actually use this to write some pretty cool apps. So this is actually, I guess familiar with Topcoder. We're a developer community where we crowdsource development through a lot of competitions. And so every year we have what's called Topcoder Open. And it's in 3 weeks here in San Francisco, and Salesforce is one of our sponsors. And what we do is we do a lot of algorithm competitions. So I use the tooling API to write an algorithm. And if you sell this algorithm correctly, you get a free ticket into Dreamforce or into Topcoder Open. And so how it works is you log in, and it gives you a random problem, random algorithm. And your job is to write the Apex to actually solve this algorithm challenge. So you write the code, and we've already written the test cases. And when you save and deploy your code, it actually runs it on with the tooling API through this org and tells you if it's right or not. So I've cheated a little bit, and I've actually put the class in here already, the code that works. So you can kind of see how in the background, this is running the, over here, you can see over here, it's compiling. We got connection here. Let's see what we got here. I may not be able to get this. It's hard to see my screen. Let's see what we got in the server here. Oh, okay, that job failed. Okay. So let's see what we got. Let me refresh here because it may not like this. Okay. We'll run it one more time here. So this is actually the log off the server on Heroku. We can kind of watch that. Nope. That doesn't like my. Oops. T. Okay, let's try this one more time here. So it does the same we just saw a minute ago, but it does it actually in a web app. So there you go. You can see down here they actually compiled the code to the server, inserted the class, deleted the class, completed the job, and that's how we got the status of, over here, of success. And then we can do things like you can actually run the tests on the server. So you can see it, do the same we just saw a minute ago. This one seems to run for a long time. Actually, it comes back. It says up here, you missed it up here. But it runs all those tests on the server. So doing the same thing what I just showed you was doing it from actually a production web app. So you can do more than just create tools with this API. You can create some really cool applications that use the API under the covers that people never know about. So we've developed this whole thing we call the Arena. We have a different language, but now we've added Apex using the tooling API, which you would never know it's using the tooling API in the background. It's pretty fast. So a couple more things. I know we're getting late here, so. All right. So a couple quick things. All right, so best practices. When you start working with this, I would either recommend you use a developer order before you start messing around, or back up your metadata first. So you can use the first IDE or Maven's-Mate and download all your metadata before you start making changes, unless you're in some kind of sandbox org. You're going to have to use a different API besides the tooling API to log in. It doesn't have a login functionality. It's like the Metadata API. You've got to use the web services API to log in and get your token, and then use that. Same thing with this one. In our case, we used Enforce to log in and get that API token, or that session token. That's what you got to do that. You can't have any login functionality with that. Also, it's really nice to save the results to disk and actually inspect them in comparison. You can do diffs on your files on disk. So sometimes instead of just putting them in the console, I'll put them to a text file. That way I can look at it easier because they spit out quite fast. And then we also use event emitters to check for asynchronous events. That's much easier than doing promises. And then last but not least, these are the links that I mentioned in here, so you can check those out at your leisure. And that's it. That's all I've got. Anybody have any questions? It was too awesome for questions?
Can you bring the links back up?
The which one?
The links.
Oh, the links? Yeah, sure. There you go. So the first one's the documentation for the tooling API. The second one is the Enforce repo. The third one is my Enforce tooling API. Then the next one is Forever, which runs it runs your node script as a basically background process. And then Commander is one that you actually use to build CLIs. And then the last one is actually the code for all this demos right here. Yes, sir.
Is there a way to kind of run the monitoring backwards, like changes that are done in production, like an admin adds a new field or workflow rule, to then have it monitor, detect that, and send an alert, said, hey, this guy did this thing?
Oh, so basically detect when someone changes something? Mm-hmm. Yeah, we did that actually with diffs. We did it in GitHub. So we'll do that, and we'll run diff. So we'll have, you have the code in GitHub, and then when you run it again and you actually get the code out again, you can download every day. We have a process that runs every day. You can do diffs on that and actually see what's been changed. So we do that, like if we're looking at a big project and we want to see how many lines of code have been written every day, you can see this guy's actually doing something every day, and we can actually look at the diffs every day and see how that's building up over time in the GitHub repo.
Oh, but I was thinking stuff that's like a new field is created directly into production with using the UI instead of using Git.
Oh, so if someone actually creates a new field in the UI, mm-hmm. I mean, if you're downloading your metadata every day, you can see that diff in the metadata that comes down. So you can do that. So we'll save the metadata, and it'll go in GitHub, and then we'll use GitHub to view the differences in there. So it doesn't really matter where they create it, either through the API or declaratively, or just click a button.
You just schedule that.
Yeah, we just schedule it. Yeah, you can actually run it on Heroku. They've got an awesome little app called Heroku Scheduler. It's free, and you can set up a cron job to run like every day, or actually every 10 minutes if you want to. You can do that. So we use that for quite a bit of stuff.
Cool.
And you can run on Heroku. It's free for one dyno. It just wakes up and runs. So it's pretty nice. Anybody else? Yes, sir. Does it do what now? You can actually specify. You can specify which classes to run. So you'll see it in this class right here. I actually specify the ID of the code to run. So you really can't see it in here, but let's see, where's it at here? It's actually right here. It's essentially an array of class IDs. So you can put one in there. You can put all of them in there, whichever one you want to run the test on. You can put in there. Yep, you can, yep. When it deploys to production, it looks the same way. It looks exactly the same way. It functions the same way. Say it one time now? Yeah, you can deploy test classes. Yeah, yep. Yeah, it's going to run all the test classes. In production, it always runs test classes when you deploy. So, without? No, I don't. You can deploy without it, but it'll fail the deployment. You won't have any test coverage. But yeah, you can do that. Yeah, I've written code in production without test classes. Because it's 75% across all classes. It's not just each class. So they don't really tell you that. So, but yeah, but you should always write test classes. Which we do. So I'm just kidding. So, but there's times when you get in production, you got to change something real fast. You got to do it. Yeah, but yeah, you should always write test classes for your tests, for your classes. Anybody else? That's it. All right. Well, thanks, Todd. Appreciate it. Have a good day.